team and loved and valued for who you are.
It's never too late to be yourself. It's never too late to find your happiness.
No matter what your identity is in the community, that there's going to be a place for you, and there's going to be a place for you to not only just be here, but to succeed and to thrive. I am a queer woman, and I am NASA.
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 There are always young people in the audience, and they always want to know when they're bringing it back, you know. And I always say, I don't think ever. I think NASA, they realizes that they have two marks, so to speak, but somehow they can be made to coexist. We had to analyze what had been done by NASA in the past. Finally, we realized though we had to have a unifier, something that was very strong to hold it all together. So over the process of working on it over the first month, I think we got simpler and simpler with our solutions so that space shuttle. We were trying to embody in the logo innovation. The organization still had aeronautics as well as space, and so that you see a kind of nose cone design inside of the A's and propulsion, kind of upward thrust. Great simplicity, but still movement.
Roger, roll, Discovery.
The term worm came out of Florida in a newspaper down there, and it was meant to be derogatory. Eventually, over the years, the worm became a term of endearment, but it wasn't meant that at all in the beginning. When they started producing apparel a couple of years ago, they found out how young people in particular really like this program, and so they've allowed it to kind of come back to life on its own. It's validation, I think, of the sort of timeless approach that we brought to this. Space is about the future, and if we can still hang in there, and if it still represents that, then it's good. To do that, to hold up for decades, and apparently it's still it's got better legs today than it did then.
California is a giant metal structure standing 100 feet tall and almost 100 feet wide. It's made of industrial strength steel that could withstand the harshest winds and rain. This monolith of the desert, located at NASA's Dryden Flight Research Center, has been an unsung hero in the life of the Space Shuttle program for the last 34 years. This steel giant is called the Mate-Demate device, or simply the MDD.
Forward and 3 inches aft, and that's all the adjustment you have.
to set it on top of the 747. You can't move it any more than that.
You gotta remember that thing was built to lift 330,000 pounds. See a shuttle up close, you watch it take off on top of that 747 when it leaves here, and it's just amazing. And you know you had something to do with it.
After the shuttle makes its grand re-entry, landing safely while the world looks on, and after the media has shut off their cameras and gone home, a vital, albeit less glamorous event. DD. After landings at Edwards Air Force Base, the MDD is used to hoist and attach the shuttle orbiter onto the shuttle carrier aircraft so that it can be flown back to NASA's Kennedy Space Center in Florida. While simple in concept, the execution of this task is anything but. Considering the average landing weight of the shuttle is roughly 230,000 pounds and holds research and payloads acquired in outer space. Carrier aircraft, a modified Boeing 747. The MDD is utilized to process the shuttle, a week-long procedure that includes taking up the landing gear, attaching the tail cone, and literally battening down the hatches.
They have what they call escape operation, and that's when they do the actual defueling. And the people that are doing the defueling, they have to be in a full suit. It's air-contained, self-contained, everything has its own air and everything. It looked like the spacewalkers.
During the week of processing, the orbiter is lifted.
The basic idea is to put the shuttle on top of the 747. That whole process involves a week of processing to safe the vehicle to put it on the 747.
Just before landing at Edwards, Kennedy Space Center deploys. With the Dryden team, this highly specialized team of engineers, pilots, and ground crew work in unison under harsh conditions, performing precision, high-risk tasks with a fragile 100-ton spacecraft.
If you don't do your job and do it right, there's always something that could happen that could lead to somebody getting hurt, harming in the shuttle. So you have to make sure your job is done and done right, and with all the expertise known and have. So
over the years, ground crews were able to perfect the art of mating and processing the orbiter, but never without risk and hardship. To fully appreciate the complexity and scale of this undertaking, it is helpful to understand how the MDD came to be and how it has served as an essential component in the success of the STS program at large. As the sun was setting on the Apollo space program in the early 70s, a new distinction between the two programs was that the space shuttle was a reusable spacecraft, unlike its predecessor. The shuttle, or orbiter, was to be lofted into low Earth orbit with the energy of 2 solid rockets and the orbiter's 3 engines fueled by an enormous external tank filled with liquid oxygen and liquid hydrogen. Upon its return from space missions, the orbiter would re-enter the Earth's atmosphere, flying without power, like a glider, and land on a long paved runway, like with an extremely short wingspan, and without the expendable external fuel tank used for liftoff, however, the orbiter lacked the ability to take off and fly like a conventionally powered aircraft in the Earth's atmosphere. From the start of the program, engineers recognized that the orbiters might not be able to return to their launch site at the Kennedy Space Center in Florida because of an engine malfunction after liftoff or because of unfavorable weather conditions.
Shuttle can't land in the rain, no. Once it breaks through the atmosphere, it starts cooling off, and there's enough space between the tile that the shuttle, the water doesn't have any place to go, so the tiles are just glued on. That's why landing at Kennedy always concerned because, you know, how much rain it gets there. And we're usually pretty dry here.
In this event, a landing elsewhere would necessitate bringing the shuttle back to Florida, which meant the need for a structure capable of lifting the orbiter off the ground and placing it on the back of the 747 shuttle carrier aircraft. Using cranes to lift and attach a shuttle program, it soon became clear that there was a need to build a permanent and reliable structure to achieve this task. Hence, the idea of the mate-demate device was born, and plans to fabricate and construct the first MDD were put into action. The Kennedy Space Center awarded a $1.2 million plus contract to the George A. Fuller Company, a division of the Northrop Corporation, to design and build the first mate-demate device. Soon after, the early stages of the shuttle program, it was especially important to build an MDD at Dryden first. Assembled in nearby Palmdale, California, the first three orbiters, Enterprise, Columbia, and Challenger, were actually trucked to Dryden. Once there, the MDD would be utilized for the first time in the historic and groundbreaking Approach and Landing Test Program in 1977. The Approach and Landing Test Program, or ALT, was an essential component characteristics of the orbiter upon re-entry and landing, and test its systems in flight. The ALT program made use of the MDD for the first time to load and unload Enterprise onto the Boeing 747 in a series of high-risk test flights in 1977. In 1982, NASA arranged to have a permanent mate-demate device erected in Palmdale. The Orbiter Loading Facility, or OLF, was originally built for use by the Air Force at Vandenberg Air Force canceled the plans for a dedicated orbiter and launch facility on the West Coast. The OLF was relocated to Palmdale.
Several years ago, they were doing refurbishment of the shuttles in Palmdale at the Boeing facility, and the orbiter would fly in on the 747, and they would fly into Palmdale, and we would offload it using the OLF, and then we would transfer the shuttle over to the Boeing folks, and they would do the shuttle modification. So let's put it back on the 747.